Hey guys, and this week's video is going to be about electrolysis, but in aqueous solutions, so in a dissolved electrolyte. And to begin, let's first figure out the difference and what defines an aqueous solution for electrolysis, or just generally. So you can have two types of electrolysis. One is molten, and this is where your electrolyte is melted. It's in liquid form, but it's just by itself. There's nothing else. And this is pretty simple. The second one, it's in an aqueous solution. And what this means is that it's dissolved. So instead of just being the solution itself, for example, if we have NaCl right here in molten, you would only have NaCl, sodium chloride. You wouldn't have anything else. But in an aqueous solution, you would also have H2O, so you would also have water because it's dissolved. And this leads to a bit more complex electrolysis and some different products that you end up getting. So let's have a look. So just to remind you, this is your setup for performing electrolysis. So over here, you have your power supply. Then down here, you have your electrolyte, which is in this case is in an aqueous solution, and this makes this circuit closed and electricity is able to pass through. And then over here you have your anode, which is positively charged, and unlike the name might suggest, and due to electrostatic attraction, the negatively charged ions, so the anions, go to the anode. That's why the name is there. Then over here you have the cathode, which is negatively charged, and your positive ions, so your cations, go over here. And what happens is that when you have negatively charged ions that go over here, so when you have anions that go over here, they release their electrons into the anode, and the electrons flow over here. So they lose electrons, which is leading back to redox, because electrolysis is just performing redox. And they move over here, go here, and then here you have a positively charged ion, and this ion gains the electrons that the anion over here gave to the anode, which followed through to the cathode and then was gained by the cations over here. Alright, so I hope this makes sense. Just a brief overview of electrolysis again, but now you have not only your substance, but you also have water. So you have hydrogen and you have hydroxide, OH. So what you're going to see is that now hydrogen and hydroxide compete with the ions, and your products are going to be different. And this competition depends on the reactivity of the ions themselves. So what you can see is that by your cathode, this is where your hydrogen will travel to, because hydrogen, let me remind you, hydrogen is positively charged and hydroxide is negatively charged. And your cathode is negatively charged, so this is where your hydrogen flows to. So at your cathode, you are always going to get hydrogen unless copper, silver, or gold is present. Then at your anode, which is positively charged and where OH travels to, you would gain oxygen unless a halogen is present. And a halogen, might I remind you, is an element from group 17. So for example, chlorine. All right, so let's do an example, because it makes sense way more when you have an example. So our example is going to be the electrolysis of copper with a charge of 2, copper sulfate, a copper sulfate solution. And solution is really your keyword over here that lets you know that it is in an aqueous solution and that water is also present. So hydrogen and hydroxide are also present over here. So let's start off by just naming every single compound that we have over here. So let's name our positively charged compounds. So for example, our cations. We know that we have copper, which has a 2+, and we have hydrogen, which has a 1+, right? And then for the negatively charged compounds, or anions also, we have sulfate, which has a charge of -2, and then we have oxygen, which has a charge of -2 as well. And if we look back here And once again, I must remind you that this is all based on reactivity of the elements. And over here, we see that we have copper and hydrogen. And if we refer back to that, we remember that copper will win, you can say win, wins over hydrogen. So that means that our product is going to be copper. So copper travels to the cathode. So this is what we obtain at the cathode. Hydrogen is then left over. On the other hand, over here, if we remember, sulfate is not a halogen, let's be clear. So here we're going to gain oxygen, so oxygen wins. So we're going to obtain O2 at the anode. So what do we have left? Left over, we have hydrogen and sulfate. And to balance this, we need 2 hydrogens, and this is just sulfuric acid. So we have sulfuric acid left after we perform the whole electrolysis. But now, let's quickly do the half equations for this in order to understand what's going on in terms of redox reactions. So let's do some half equations based on this theoretical experiment. So at the cathode, which is negatively charged, we're going to have copper. And copper has a charge of 2+ at the beginning, right? And in order for it to have a full outer shell, it has to gain 2 electrons. And then it turns into copper. And this is what we obtain. This right here is what we obtain at the cathode itself. So copper gains electrons, so it is reduced, so a reduction occurs. Because if you remember the abbreviation oil rig, oxidation is loss of electrons, reduction is gain of electrons. And here we gain electrons. So we're going to have reduction, so copper is reduced in this case. Then at the anode, which is positively charged, we are going to have oxygen. And oxygen has a charge of -2, so it's going to end up losing these electrons. So we're going to have oxygen plus electrons. But this isn't balanced because we need a 2 over here, and then we will end up having a 4 over here because 2 times 2, that means there's 4 electrons over here. So this, if you look over here, this is not a part of oxygen anymore. So there is a loss of electrons. And if we remember oil rig, a loss of electrons is oxidation. So over here, oxidation has occurred. So I hope this makes sense, and I hope you're getting a bit more familiar. And basically, the only way that this is different is that now you have water. Now you have H2O, which ends up being hydrogen particles and hydroxide particles in there. So now they're also competing with your electrolyte or your pure electrolyte, which you wanted to have, and this will determine. So for example, here, as we've seen, you are going to get copper, but you're not going to get sulfate, right? So this is something to keep in mind when considering your products of electrolysis when you perform electrolysis. Alright, so I hope you enjoyed the video, and I hope you got something out of it, and see you next week.